In this video, we're going to continue looking for global or absolute extreme values. So let's look at this last example, number 5. So in order to find those global or absolute extrema, we need to find the critical points and the endpoints. So let's start by finding those critical points. So to do that, we need to compute the derivative of f of x rather. So again, as we've been doing, please pause the video and work this out on your own first. Awesome. Now let's work together. So the derivative of x squared is just 2x. Derivative of 3x to the 2/3 is 3 times 2 over 3, x to the power of negative 1/3. Call our power is 2/3, so we subtract 1 to get negative 1/3 in that exponent. So now we can just simplify and clean things up here. So our first term is just 2x. The second term, the 3's cancel. That negative exponent goes as a positive exponent if we include x in the denominator. So that looks like minus 2 over x to the 1/3. So now let's check. Is our graph ever undefined? By graph, I mean function. Is our function ever undefined? Well, we have a rational part of our function, so it will be undefined whenever this denominator is 0. So when will x to the 1/3 be 0? When x is 0. So we do have a value where our function is undefined. Our derivative function is undefined at x equals 0. So check, did that. Now we need to find where our derivative is equal to 0. So where f prime of x is equal to 0. So let's set up that equation. So it looks like 0 equals 2x minus 2 over x to the 1/3. So here we need to solve for x. And one thing you'll notice is we have an x in the denominator of the term here and an x being multiplied here. So the strategy is to multiply both sides by this denominator in order to cancel that denominator and combine our x terms. So let's do that together. So I'm going to multiply by x to the 1/3 on both sides. So that side and that side. On the left-hand side here, 0 times x to the 1/3 is just 0. So I'm left with 0. Then over here, when I bring in that x to the 1/3 into this whole right-hand side, I get 2x times x to the 1/3 minus 2 times x to the 1/3 over x to the 1/3. So those x to the 1/3s cancel. I'm just left with 2. So now I can combine some terms. So I have an x to the 1 power times x to the 1/3. So that just becomes 2 times x to the 4/3. I'm just going to add the exponents here because I have the same base, minus 2. So solving for that x, can divide everything by 2. Left-hand side, I just get 0. Right-hand side, I get x to the 4/3 minus 1. So therefore, I can add 1 to both sides, and I get 1 equals x to the 4/3. So solving for x, I can raise each of these sides to the power of 3. On the left-hand side, again, nothing too exciting happens. I still get 1. On the right-hand side, that exponent cancels, so I just get x to the 4th. So this means I have 2 options for x. I'm going to have plus or minus 1. So x to the 4th, whatever I raise to the 4th power will become a positive, and my value I get out in the end is positive 1. So if I raise 1 to the 4th power or negative 1 to the 4th power, I still am left with 1. So my solutions are x is equal to plus or minus 1. All right, so now I have a few critical points here, which makes things exciting. So just to summarize, we get our critical value of x equals 0 from the derivative being undefined there. And we get the critical points of plus or minus 1 from when the derivative is 0. So critical points at x equals 0, -1, +1. Okay, so now we want to check for local, or actually rather in this case, global or absolute extrema. So we need to test some points. The points that we test are going to be those critical values and the endpoints of our interval. So we're going to check when x equals 0, when x equals 2, when x equals +1, when x equals -1. And because a critical value occurs at that endpoint, I don't need to check it twice. All right, so the test points are the x values here. And how do we test them? Well, we're going to compute the function output to see what output is largest or smallest. So we have our function f here, recall. So what I'd like you to do is plug in your x values into your function and determine the output in each case. Please pause the video to do this. And when you're ready, play the video to check answers. So one thing you might have observed while doing that is that this value x equals -1 is not actually in our interval. So we can remove that as a candidate of a possible extreme value right away. So then we just check the function outputs. So when we plug in x is 0 into f of x, f of 0 should be getting 0. When we plug in 2, we're going to have to use a calculator on this one, should be getting something close to -0.7622. When you plug in 1, you should be getting -2. So of these values, which is the largest? Awesome, 0 is actually the largest number. So here is our global max. And what about our smallest number? -2. So our global min is -2. And recall with that language, it's subtle here, but we say that our global maximum, or the maximum value of our function, maximum value emphasis, is 0, and it occurs at x equals 0. The minimum value of our function is -2. That's as small as it's going to go, but it occurs at +1. All right, at this point, feel free to graph this function just to get a sense of where these critical values and these extrema occur. And then from there, finish the questions in this video lesson. So thanks for watching, everyone.